All right, so basically you have a curve there and you have the change in y. Let me make it kind of a little bit better. And what happens is we define the derivative as the limit of the change, and they make that squiggly line so weird. I never used to make it that way. Change in y divided by the change in x as the change in x approaches to 0. So as we make it smaller and smaller and smaller, we get the derivative, and we can now say the derivative is dy over dx. And this is a similar type of let me see how I spell Leibniz. I don't want to Leibniz. So this type of notation here is Leib. I never learned to pronounce his name right. Let me spell it better. I don't know how to pronounce his name. Notation. The teachers always did it properly though. So that's how you. This means the derivative. Usually, the way we've done it so far is we've used y prime. We've used right time. Y prime. This is. Well, Newton used dots still, but that's what we use. Y prime equals dy dx. And now there's an advantage to using this, specifically when we discuss changes of rates and things like that. It's a nice way. So we have f prime of x, we have y prime, and we have dy dx. Now, what that lets us do at some point, something called variable separables, but that's for differential equations. I don't think we do that in this class. But perhaps we want to do some problems that are interesting with respect to this, because you don't really see what's interesting about this until you do a problem. And that's what I want to do. So let's go ahead and write down a problem here. I think I'll pick one like on page 110. It says a ball, number 7. A ball is thrown vertically upwards. All right, so what do you think? You're gonna throw it like this, right? Vertically, up. And it says at time t seconds, its height h meters is given by h equals 20t minus 5t squared. And it says calculate the ball's maximum height above ground. And so I'm going to have to scroll up over there too. And let's discuss this before we even start. So you know by experience, if you were to throw a ball up in the air vertically, like perfectly vertically, it's going to reach a maximum height and it's going to come back down. And apparently, if you know how to catch, you'll catch it. And now they give you a formula there. They say that the height is equal to 20t minus 5t squared. We're assuming that t stands for time. Okay. So that's a parabola, by the way. So you know, and is that parabola facing up or is it facing down? Down. You could tell it's facing down because of that -5 in front of the t squared. So remember that the variable with a squared exponent, if it has a negative coefficient, it will face down. If it has a positive coefficient, it's face up. So if we remember from last class, when did we find stationary points or maximum or minimums? When the what? When the derivative equal to? Okay, so if I were to sketch this, this would look something like this. And if I did my derivative, positive derivative, increasing. Positive derivative, because the slope is positive. Positive, positive, positive. But as I get to the, I guess you could say, what is that called? The maximum? The crest? What do you say? The crescent? No. The apex? I don't know. It doesn't matter. Here's the point. Right here, what's the derivative of that slope right there? What's the slope? Sorry, the slope of that tangent line. It would have to be, when it's a horizontal line, what's my slope? 0. And so at a maximum or at a minimum, our derivative will register a value of 0. So if we wanted to figure out the maximum height, what do we want to find out when the derivative is equal to 0? Okay. A lot of blank stares. Not good. Okay. So I don't want to graph this, but I'm going to be forced to graph this. It doesn't look nice, though. I don't want to graph it. Can I say that any other way? All right, so let's go ahead. I'm going to stop this share. And I'm going to go ahead and try to do it with Desmos. But the thing is, when I do Desmos here, you won't see it up there unless I share my my theme. So I'm going to go ahead and share it. And the panel error, it says there's a panel error. You know what? I'm not going to share anything. I'll just do it. I'll do it twice. So Desmos calculator. I'm going to go ahead and graph this for a second because I think it's worthwhile that I go over these points with you. Very important. So I'm going to write instead y equals to, oh, lovely. This doesn't have like equals to. Why is it y? It's going to take me forever to do. Equals to 20t, 20x in this case, minus 5x raised to the second. All right, so I did it here on this thingy. I'm gonna go ahead and share this on my Zoom. So I'm here, Zoom. Share the Desmos. Share. And am I recording still? No, I'm still recording here. So you're gonna see this on the video, and I'm gonna also do it on the board here because I'm not gonna be mirroring my desktop. So here we go. Desmos. Come on, computer, hurry up. That was pretty quick though. Might have been cached. Oh, it's quick. Y equals to 20x minus 5x raised to the second. So if we take a look at this right here, this is the parabola as being described. Now, initially it had a height of 0, apparently, and then it climbed up to 20 feet, and then it came back down. That's what it said. So this person threw the ball pretty hard. So that's what it shows there. Now, what you have to realize is that all these, when you do the derivative at 0, for example, you'll get a slope. Okay, and you do it again and again and again. And this guy is the only one which will have a slope of 0. So if you wanted to find out, I have boogers, guys. Let me clean myself with my shirt and my hand. I'm sorry. So if I did this, I know that the derivative here is what? What's the derivative at that maximum? It has to be 0. So therefore, I don't have to worry about graphing the equation. I can just find my derivative. And then once I find that x value, my derivative equals 0, I find that x value and I substitute to the original and I would know my So you guys are not scared about Corona. So let's do that together. So let me go ahead and go back to the question. And make sure that I stop the share, but I also change the share to Microsoft, whatever it is, whiteboard. So here we have the ball. We're gonna go ahead and do the derivative of h with respect to t. So we say dh dt equals, what's the derivative of 20t? 20. What's the derivative of negative 5t squared? Negative 10t. Now, we have a stationary point when dh dt equals to 0. So 0 equals 20 minus 10t. So we have 10t equals to 20. So t equals to 2. Now, if we remember correctly from last class, we can determine whether this will be a maximum or a minimum. We know it's a maximum by the shape that we just talked about, but we should also remember that we can take, and I don't want to, we can take the derivative of derivative. Yay or nay? So here's how we do it. So this is how we write the second derivative must equal negative 10. So we said that if it had a negative concavity, then it's going to be a max. So if it's a negative, if it's a negative, meaning if it's less than 0, it will be a maximum. It would be max. Right? That's what we said. If it was going to be a positive, it would be a minimum. If it were 0, if the second derivative were 0, we would say that is an inflection point. It's like a slurve. Okay? So remember, if your second derivative, I'll write it here. If second derivative is less than 0, we have a max. If it's greater than 0, we have a min. And if it equals to 0, we have an inflection or transitory point. Inflection. So this one will look like this. This one will look like this, and this one will look like that. So in this case, we do have a max. So I guess I'll do it over here in blue. Let's do it here. This is will solve the what they want. So we just go ahead and go to the original formula and we substitute t equals to 2. We know it's going to be a max. Okay, and we'll find the maximum height. H equals 20 times 2 minus 5 times 2 squared. So H equals 40 minus 5 times 4, which is 40 minus 20, which is 20. And so the maximum height is 20. Let me write it. There you go. The maximum height is 20. And that's an application. That's an application derivative, one of the simplest ones. Fair enough? Yes. Only if you are here.
Mr. Can you scroll it up?
Of course, I can. Look. So obviously, I hope you like the problem. Is it too bad? Let me see who's texting me. It must be my wife. And of course it is. Why is my wife saying, ¿Cómo me siento? I was going to tell her that. Bien. Bien. Good job. ¿Cómo te sientes tú? ¿Y la bebé? All right. Questions or concerns? Yes.
You said it was inflection or what?
Inflection or transitory? Transitory, if I remember correctly from college. Okay, so let's try another problem. Oh, my wife texts me again. Me duele la cabeza, pero no mucho. Estoy recogiendo la casa. La bebé ahí ahora no le duele. Okay, my baby, the baby fell. Well, she didn't fall. She got angry and threw herself on the floor. And she messed up her elbow and dislocated her elbow. And we had to take her on Halloween to the children's hospital so they can put her elbow back in place. And they did x-rays, it's fine. But she's like, she doesn't want to move her arm. So yesterday she spent the whole day, and I'm like she go like this to me or her right hand, but she wouldn't. I'm like, on la otra, she's like, she didn't want to move her arm. So hopefully she'll get better. You know, I'll be able, because she's lefty. It seems like she's lefty, but I don't want her to turn into a righty because she dislocated her elbow when she was 2. You know, it'd be dumb. But a lot of people say it's better that she turned out to be a righty, which is true, but whatever. Okay, so let's take a look at another problem. I think you'll like these problems because they're useful. All right, it says here, this is page, by the way, this is page 110. The sum of 2 real numbers, X and Y, is 12. Okay. Find the maximum value of their product. So that's an interesting little question. But again, if you haven't done these questions before, nobody's done it with you before, you don't know how to even proceed. But let's play the game. Let's play the game. So it says there, okay, the sum of 2 real numbers, X and Y, is 12. So here's what you do. You go X plus Y is 12. And it says, find the maximum value of the product. And you're like, okay, if I take X times Y, I'll get P, the product. And now I'm supposed to figure out, like, what's the maximum product? You're like, okay, well, I can do 1 plus 11. 1 plus 11 is 12, but 1 times 11 is 11. But then you're like, okay, let me try 10 plus 2. 10 plus 2 is 12, and 10 times 2 is 20. Ah, that's more than 11. So there has to be a combination of numbers that adds up to 12 and at the same time has a maximum value. And we have to figure those out. You can do it that way, which you can try numbers over and over. But like you also have decimal values. You can have like 8.1 plus 3.9 also equals to 12, and you can multiply them. And you can do it like that as a method of exhaustion, or you can use calculus and algebra. So how would I begin this? Well, first of all, I would maybe want to rewrite what I know differently. You'll see why. Like I can go y equals 12 minus x. Because y would always have to be 12 minus x. Or vice versa, you can say x is equal to 12 minus y. But what that lets me do now is when I write this p here, instead of writing y, I can write it as x times 12 minus x. Do you see how I replaced the y with the 12 minus x? I no longer have a different variable there. In fact, p is really going to be 12x minus x squared. And guess what that is? That's a freaking parabola. And it's facing down. Don't you see it? It's the same question we just did. See, that parabola will describe, if you plotted that, that'll give you the products of each of those numbers when you multiply them together. You pick an x. When you pick an x, you do 12 minus x, that gives you a y. If you do that, y times x, you get the product. That gives it to you automatically. And so now I'm going to go ahead and do the derivative of p with respect to x, which is going to be 12 minus 2x. I realize that this is facing down. It's going to be a max. If I got to show it, I can do the second derivative with respect to x is equal to -2. Since it's less than 0, we have a max. And let me scroll. We have maximum, right? So then I can go ahead and solve for now. Remember, this is usually we have to use our test points. So we don't do our derivative until we do our test points. So when dp dx equals to 0, we have 12 minus 2x. That's when we test for stationary points. 2x equals to 12, x equals to 6. And so now we substitute into the original, the x equals to 6. So y equals 12 minus 6. So y equals to 6. And it makes sense. It makes sense. The maximum value is 6 times 6, which is 36. That's the maximum value. So what you'll find this originally, you'll find y by substituting in here, right? And then once you have your x and you have your y, then you go ahead and substitute the x and the y in the p, which is x times y, which is, the product. And now you have your maximum value, which is 36. And you didn't have to do a method of exhaustion of guessing. You could figure it out using some very simple calculus and some algebra. Make sense, people?
Why did you multiply the 6
What x value did I get? Right? The x value was 6. And when I substituted and found the y value, what was the y value? And what was the question? The question asked at the beginning, find the maximum value of their products. The products of whom? Of x and y. So I just put 6 times 6, which is 36. Does that make sense? Let's do another one. Again, the best thing I can do is just give you a bunch of examples, and hopefully, after all those examples, you have something to work with. And obviously, it's new. It's new. So let's see if there's more interesting problems. It says here, so it says here, page 110, number 10, it says the volume of a cylinder is given by the formula V equals pi r squared h. And it says find the greatest values of the volume if, and they give us a restriction, if r plus h equals to 6. So if we add the radius and the height, we're eliminated to being 6. What would be the biggest volume? So again, this is a similar question to the last one we just did. There's various combinations of radius and heights that will equal to 6. In fact, we might say there's an infinite combination of radiuses and heights that will add up to 6. However, there's one combination which will give you a maximum. And that's what we want to find out. So what I do is, again, like the previous question, I might want to rewrite, instead of writing r plus h equals 6, I may want to say h equals 6 minus r. So that when I look at my volume is pi r squared h, I can replace the h with what? With 6 minus r. And the reason I did that is because I want one side of the equation to have only r's or h's, and the other side to be v. So right now, what we have essentially is we have dv equals pi, and let me write it better, 6 pi r squared minus pi r to the third. That's if you distribute that. I can find the derivative of that. Right now, I don't have the tools to find the derivative of v pi r squared h. I don't have it. I just don't have it. So what I did there is I described the height in terms of my radius. That little trick allows me to now write my volume in terms of the radius only, right? And now I can go ahead and take my derivative, dv dr, which in the first case is going to be 12 pi r minus 3 pi r squared. And that is my derivative. Now notice that the pi is being treated as a constant. Pi is a constant. It is an irrational number, so I don't need to write it as 3.14. I just leave it as pi. And now, once again, we have, basically, that's a parabola that's facing down. We know we're going to have only a max. We have a stationary point when dv dr equals to what? 0. So 12 pi r, all right, nicely. 0 equals to 12 pi r minus 3 pi r squared. So 3 pi r squared must equal to 12 pi r. When I divide both sides by 3 pi, notice that the pi's cancel. And I'm left with, wait, I saw something. Yes. No, you're not. Yes, you are, but whatever.
Oh, you're doing that.
Yes. What's up?
Stats?
Yeah. Ace.
Ah.
Yes.
Sure. Okay. Look, what does that mean
Algebra and personal finance.
for college?
That's a slow math.
Really?
Yes.
Because that's for the biology program.
So do it. That's what they. I got a pimp.
I got accepted.
Oh, congratulations. Do I have a pimple behind my ear?
Behind your ear? No.
Congrats, mama. Congrats.
I got SMDC. I got deferred from Afayuga.
Okay, that's all right.
It's okay, because I'm gonna do MDC and then transfer.
That's fine.
Or I'll just go to this one, then university in Boca Raton. Mister,
Yes.
just one more step closer to becoming a doctor. Hey, if you ever need liposuction or Botox, let me know, because that forehead of yours needs it.
That's kind of mean.
It's not mean. Mister, you're mean to them.
Yeah, but I have to keep those lines. That's just who I am.
I'm sorry.
I don't want to ever change anything about myself.
How's your wife?
My wife is good.
I heard about the thing you're trying to do to her.
Yeah, I'm gonna get the injections today.
Mister,
Yes.
just stay with the girls. Don't involve a boy in it.
There's only one life I got to live.
Girls are better than boys. Look at me. I was your best student. Your favorite student. in
Remember,
fact.
boys and girls, we're all human.
Right.
We're just different sides
Ladies
of the
are
same
fun.
coins. You can't have it's a wonderful thing to have boys and have girls or males and females.
But you already have 3 kids.
I know. I'm gonna be poor for the rest of my life.
Yeah, bro, you have no side hustle. How's the food business going?
That's okay. That's okay. It's
Is
just,
it
you
just
know,
okay? Because bro, I heard you got bank from last year.
I made some money last year.
And then your daughter shares my name.
I gotta get back.
Okay.
Take care. Congrats.
Thank you.
All right, guys. So we got this thing here. We got 12 pi r minus 6 pi r, and I stopped it because I was like, bro, am I making a mistake? I think I was. So let me go ahead and just do something here. You can factor this as 3 pi r times 4 minus r. I think that's the way we're supposed to do this. So we got 3 pi r times 4, that gives you 12 pi r, and you got 3 pi r times negative r, that's going to give you negative 3 pi r squared. So that's good. So either you have 3 pi r equals to 0, or you have 4 minus r equals to 0. And you can tell that r is either going to equal to 4 or r is going to equal to 0. That's interesting, because what we saw here is we saw that this was the original function was the third power. You see? And so that means that third power could be something like this. It could be that little swerve I just made, where you could have local minimums and local maximums. You see, that's important. that's the thing with things to the third power. You can have, if you have to the third power, you have, up to 3 solutions that can happen. Up to 3 real solutions. Sometimes you have 3 complex solutions. But that's what we have. So now we got to figure out which one is it. And we can see it's going to be 4. I mean, you can tell it's 4. But, if you put, let's go ahead and substitute. I mean, we can figure it out right now. All right. Like if we take the second derivative of v with respect to r, right? So that's how we write it. Let me go ahead and scroll it up. If we do that, we're going to get a linear equation, right? So it's going to come out to 12 pi minus 6 pi r. So now all you got to do is substitute. If you put in 0 here, if you put r equals to 0, you get 12 pi minus 6 pi times 0, and this just comes out to 12 pi. So this is obviously positive. If it's positive, the way I think of positive is I think of positive curvature, which will look like this. So that's positive concavity, which will be a minimum. If you pick r equals to 4, right, you got 12 pi. I should have put this equal here. You got 12 pi minus 6 pi times 4. You could already 12 pi minus 24 pi is going to come out to negative 12 pi. That's going to come out to negative concavity. So this is going to be where your max is. Your max is going to happen with the r equals to 4. So now you can come back up here, but I'm not going to do that. I'm just going to rewrite everything. So originally we had h equals 6 minus r. And then the volume was pi r squared times h. That's for a cylinder. So 6 minus 4 is 2. So our radius equals to 4. Our height equals to 2. And then we can substitute in the volume to find the maximum. And so you could just write this as 16 times 2, that's 32 pi. And that's your answer. You didn't see it because for some reason I decided always do this exactly so you don't get it. So what we do is go back to the original equation, we find our h, and we substitute it into the volume. Make sense? No? Once you master this, then you can, if you know how to do this, it's possible because you understand the root and go wrong. The way you should approach this thing, I think is at the very least, I've done a few problems in class. So when you get home, you're like, okay, I know he did these problems. You look them over, you write them down again, and then you do them on your own and see if your memory did that, was able to transfer over. And then as soon as you understand what those problems are doing and you can imagine it, then you try doing some of the other ones that I assigned you, which are going to be nightmares. And then if you can't do it at home, when you come to class, you ask me, and hopefully I do it. If you invested the time, then it should click. Maybe it clicks when you're like driving home or something. But that's how you have to be to learn this more difficult stuff. You have to get obsessed with it. If you don't get obsessed with it, if you just let it defeat you, then you'll never learn it. But give it enough time, a day or two or a week, you will get this. Because at one time, I didn't know how to do these things either. And I'm no better than you are, right? Okay, whatever. I'm trying to be positive, guys. All right, so let's pick a problem. Here's what I want to do. Let me stop the recording. And I want to put the problem on the board. And I want us to read it together. And I want to gauge, and you could talk to me and say, what am I supposed to do? So. Yes, be careful. So let me pause the recording. I need to make money. You know, you can't. All right, so let's do the most difficult problem it looks like they have there. And again, remember, guys, and this is what I would like you to understand. Yes, I get it. You're not going to MIT. All right. Yes, I know you're not an Einstein, but that doesn't matter because you can still learn this stuff. You can enjoy the beauty of it. It is something nice to know and nice to know that you can actually figure it out. And yes, you can, some people can say, oh, well, you know, you're not the best at it. So what? You know, that's not what, you know, most of us, and when we do the statistics part of the class, most of us realize and should have already realized that we're mostly average. And that's okay, because that's most of the world's taking place there. Remember that most of the world's taking place in between the extremes, and you just need to try and do the best you can in those extremes, between those extremes. So you don't need to be the best. You just need to be, you know, as passionate as you can be about what you're doing, which I think this is awesome. All right, let's see. Oh, all right. Number 14. This question is really weird. It says here, an open rectangular box is made with a square base. Okay, so here we have a box. Let me draw it out. I'm gonna try my best. All right, it's drawn with a square base. So I'm gonna go ahead and indicate that the base is square. So the base is square. I'm gonna say it's a square. You guys realize that's a square? All sides equal? Oh, you can't see it. You guys are looking at me like, okay. They make sure I'm sharing. Oh, there. We got it. I'll repeat it again, and let me make sure I'm sharing the correct screen. I don't want to mess up. Wow, my face came out. So there we go. That is an open rectangular box with a square base. So it's not a rectangular box, it's a square box. But whatever. And its capacity is to be 4,000 centimeters square cubed. So the volume, it can hold a maximum volume of 4,000 centimeters cubed. Then it says, find the length of the side of the base when the amount of material used to make the box is as small as possible. So let's call this here side. And it wants you not to figure out the maximum. It wants you to figure out when you use the least amount of material. Now, an important thing is we don't have a lid here, so we don't have to worry about the lid. Okay, so how much do we know the height of the box? We don't know the height. And we don't know the side either. So you can imagine that we have a fixed squared base. And then we're going to control the height such that we have 4,000 centimeters. But we want to use the least material as possible. Interesting. So let me just call this here H. So we're going to say that the volume equals S times H. So it's HS squared. So we know that. In fact, we know that if we take H and we multiply S squared, we're going to arrive at what volume? 4,000. We know that. That's a given. But we also know that we want, it says here, find the length of the side of the base when the amount of material used to make the box is as small as possible. I'm thinking that's surface area. So I'm going to go ahead and say that the surface area of the box is made up of the base. So let's see if I can, the base is going to be S times S. And then we have 1, 2, 3, 4 sides. 4 sides that are S times H. In other words, the surface area is S squared plus 4SH. Do you see that? Do you see how I came up with S squared plus 4SH? You're leaving us? Okay, so do you see how I came up with this? Some of you are like, it's not hard. The bottom is S times S, and the sides are S times H. And we have 4 sides. We don't have the lid. So that's gonna tell you how much material you have to use to make the box. So, well, the easiest way I see to work on this, you can do either way, but I'm gonna say that S squared equals, it doesn't matter which way you cut it. You know what? I'm gonna work with H. Whatever, it doesn't. H equals 4,000 divided by S squared. Do you see that? Do you see what I did there? Yes or no, maybe? What's H? 4,000 divided by S squared. So now I may write this as S of A equals S squared plus 4S times 4,000 S squared. So I'm gonna simplify that a little bit so I can, you know what I'm gonna do? I'm gonna get the derivative. So that's S squared plus 16,000 over S, because one of the S cancels. So you may write this as S squared plus 16,000 S to the negative 1, because we don't have the tools yet to figure out the derivative another way besides the power rule. So now you may say ds of A over ds, I guess bad letters, equals 2s minus 16,000 s to the negative 2. Yes. Only be careful. So now we say there's a maximum or minimum when, obviously you can write this, let's write this way to take an analysis of it. So you can see S can't exist when it equals to 0. Okay. So let's go ahead and solve this. So we have a maximum or a minimum. Let me scroll that up. You know what? I'm not gonna scroll up. I'm just right here to the side. So when ds of a over ds equals to 0, you have 0 equals 12s minus 16,000 s squared. And so I'll write that in. So how do we solve that? Any ideas? How do we solve that? That's a 12s. Let me make it. All right, see if this step makes sense to you. Does that make sense? Yes. I like that, yes. So this becomes s to a third, right? And then you take 16,000 divided by what? 16,000 divided by 12. So I could just write 16,000 divided by 12 equals s to the third, right? I think that reduces nicely, doesn't it? Yeah. 16,000 divided by 4 is 4,000. So this is 4,000 divided by 3 equals s to the third. So s must equal the third root of 4,000 divided by 3. And it has to be the third root. I hope I got this right. You know what's spending all this time getting it wrong? It feels like I'm getting it right, but I always know if I get it right at the end. It feels right, but sometimes it feels wrong. I don't know. It doesn't matter. It's just weird that they will give you a problem like this with that looks so ugly. I don't like how the problem looks. Oh man, my calculator ran out of battery. Where's my there's the charger? The cable for charging. Okay, so let me charge my calculator right now, guys. Anything else? Let's see if it turns on though. It's not happy about the battery. Come on, computer. Okay, so what does that come out to? What does the third root of that come out to? What does the third root of that come out to? Nobody wants to talk to me? You're what? Tired of what? Life. What question was this? What number was this? Let's say I did it super wrong. Oh my gosh. More wrong, I couldn't have done it.
It's wrong.
Oh my gosh, yeah. Wait, let me just, I might be wrong, but it looks like I might be, let's just wait, give it a second. Yeah. All right, let's go through the question, see where my arithmetic mistake or whatever it was is. All right, so did I write everything right? The answer is yes. We got 4,000, that's good. HS squared is equal to 4,000, that's good. All right, the surface area is good. All right, so now we did our surface area, S squared plus 4,000 times 4 is 16,000, and one of the S is canceled. That's good. Negative 16S to negative 2, that's good. Where did that 12S come from? There it is. Nobody tells me anything. That's not supposed to be a 12. It's supposed to be a 2. Why did I write a 12 there? You see this here? You see this here? This is supposed to be a 2. Where did that 12? It happened here. Right there is where it happened. So for some reason, I wrote 12S instead of 2S. So now I can erase all this here, just this part, and write 2S instead. Right? 2S here. And then when I divide over here, so we're supposed to have this. And then we still multiply. So we end up with 2S to the third equals to 16,000. And you divide it by 2, 8,000. Right? And so now you get 8,000. Still feels wrong, but whatever. But it looks better though. Yeah. Because I wrote a 12 instead of a 2. So S equals the third root of 8,000, which is 20, and that's the correct answer. So the math is right, but for some reason I wrote, nobody saw it. Why did I write a 12 there? Why did I wrote? I mean, it was 2S here, and when I rewrote it, I wrote a 12, and then, boom, but that's correct. But what happens is when you're done, when you would substitute, when you get the value you get, the way you check yourself is you come back here, and you plug it in, and if it doesn't come out to 4,000 volume, then you know you did something wrong. And that's why you gotta write all your steps down. Okay, but that's the hardest question on there. And it's not that hard when you look at it, right? The question is, can you put this together? And can you read it and put letters instead of numbers and understand what the letters are saying? If you can do this, then you're good. If not, then you're not good. All right, guys. Any questions or concerns? All right, I think that's it for today. I'm gonna post this up and I'm gonna assign home. computer. No, no. No. Oh, I'm still in the meeting.